On this video, we will be tackling task 12. And in task 12, we need to do discounting again, but this time on the simulated costs and qualities from the Monte Carlo simulation. So on the right of the screen, I have the discounting sheet open, and you'll see that for this task, the sheet has opened up a bit further. We have some more rows that are visible. And we now have, previously we just put formulas into row 34, and we now have some rows below there. And what we have here is the discounted costs. What we will have are the discounted aggregated costs for treatment A in every iteration from 1 to 1,000. We're just going to do the first couple here, and then the rest will be completed for us. And then there are some rows above where we can calculate the mean of these 1,000 values and the 2.5 percentile and the 97.5 percentile that allows us to get a 95% range around these discounted aggregated costs for each of the cycles. Okay, so the first thing we need to do is we need to pull in the aggregated cost for treatment A in cycle 1, which is on the simulation sheet. So that came out of our Monte Carlo simulation in the previous task. And then we need to apply discounting, and we can use the same discount factors that we calculated way back in part 1. Okay, so we're going to do a formula here, equals, and we're going to pull this in from the simulation sheet. So we need the we need the aggregated cost. It's not discounted yet. We need the aggregated cost for treatment A in cycle 1 from the simulation sheet. And it looks like it's this one here. And then if we go back to the discounting sheet, what do we need to do with this? We need to apply the discount factor, which is in row 24. So we're going to multiply that by the discount factor here. Now, what's going to happen to this formula is it's going to be copied across the different cycles. So across the different columns, and that's fine. That will be, right now, it is doing that. So as we copy it across, simulation D33 is going to change to E33, F33 as we want it to. And D24 is going to change to E24, F24 as we want it to. So this is good. However, it's also going to be copied down across all of the iterations. And the simulation D33 will change to simulation D34, which again is what we want. However, do we want the D24 to change to D25, D26? No, we don't, because then it won't be applying the discount factor. So we do need to lock something, but it's only the 24. Okay, so don't put the dollar symbol before the D. Don't put any dollar symbols in the simulation D33. Okay, so that looks good to me. I'm going to press enter. So it's pulling in that simulated cost, which just happens to be this one, by the way. This is now, when it's probabilistic, this is no longer showing the deterministic discounted aggregated cost. This is showing those for the current iteration. And so because on the setting sheet, this current iteration is 1, that is why these values in this row here, in row 34, are the same as these here. Okay, so that looks good. That's been done now, and you can now see all the way down to row 1000, iteration 1000. Okay, the next thing is to calculate the mean over these. Now, in spreadsheet packages like Excel and Google Sheets, there isn't a mean function. Instead, we use the average function. So just be aware of that. There's a median function and a mode function, but not a mean function. So we need average. And we're going to click on the top one. Hopefully we can do Control-Shift down. Yeah, sometimes it doesn't like it in Google Sheets, but sometimes it does. So that looks good to me. And of course, that's going to be copied across the columns. And I don't think we need to lock anything down to do that. So that should just work as it is. Okay, yeah, it's happy with that. Okay, so the next thing we've just completed 12.2. Now 12.3 is unlocked. Calculate the bounds of the 95% credible range for each cycle. So to get that 95% range, we just calculate the value at 2.5% and then the value at 97.5%. And the gap between them, of course, is 95%. So that's our 95% credible range. So how would we do that? And we can use the percentile function. And the percentile function requires that we put in the percentile in question. And we actually have those written here. So we can write a function that pulls in 2.5 percentile from here. And then when that gets copied down to row 46, it will pull in the 97.5 percentile from here. We don't need to hard code them in any way. Okay, so what are we going to do? We're going to put equals percentile, then open a bracket, and it's the percentile of all of this data here. So I'm going to click on D49, hold down, Control Shift and down, and that's the range all the way down to iteration 1000. So that's the range of data. And then what percentile do we need? We need to put a comma in. And the second part of this percentile function is the percentile itself. And in this case, for D45, we're looking at the 2.5%. I'm going to just click on that cell that has the 2.5%. I'm not going to hard code this. And that is because this formula will be copied down to row 46. And at that point, I want it to pull in C46 instead. Okay, so we're almost there, but we need to think carefully about whether to lock any of the rows and columns, whether to apply any absolute cell referencing here. So let's have a think. As this gets copied down, what's going to happen to this? When this gets copied down, D49 will change to D50. And that means we're now missing out on iteration 1. So that's not a good thing. So we actually want to lock the 49, and we should lock the 1048 as well. Do we want to lock the Ds here? No, because when this gets copied across to column E, to column F, we want this D49 to change to E49, so we won't lock them. Now, what about the purple one here, the C45? When we copy this down, we want C45 to update to C46. So we are not going to lock the 45. However, when this gets copied across to cycle 2, cycle 3, we want this to remain in column C. So we're going to lock column C, like that. Okay, so hopefully that will work. Let's test it. And these are tricky, these formulas, where they get copied not only across the columns, but also down the rows. But it looks good, it's correct, and it's copied correctly. Okay, fantastic. Okay, so what's happened is those iterations from 3 to 1000 have all been hidden just for now. And what's been unhidden are all of the cycles up to 61. And the reason that those iterations from 3 to 1000 have been hidden is just not to give away what the formulas are that we need to put in here. So what will the total be in that cell? What do we think? Okay, if we think back to earlier, we typed this formula in the first part of the exercise. Remember, we had to take account of the half cycle correction. We also had to take into account the possibility that the time horizon changes. So quite a difficult formula. Now, that logic ought to apply the same to this cell here. Okay, so it says here on the left in the instructions, you may be able to copy and paste your formula from BM34. That's this one. Well, let's try that. So let's copy that. And then here I'm going to paste it. And that will be automatically copied down. And the reason this works is I'm only interested in the costs from that particular row. So this is why this works. So paste the formula this time. The other thing is, you see this blue cell here. The reason it's blue is just to highlight it. This is an extremely important cell, and this will be appearing on the probabilistic result sheet a few tasks from now when we get to the probabilistic result sheet. This is if you recall correctly, row 44. If I just go back, row 44 is the mean. So this, and of course column BM is the total. So this is the mean of the total discounted aggregated incremental costs for treatment A. So this is really important. And the shorthand that we would give to this is it's the cost of treatment A. But that shorthand is doing a lot of work, of course. It's it's the mean averaged over all of these 1000 iterations, and it's aggregated across all of the different states. Remember, we did that back on the model sheet. And it's totaled across all of the cycles given our time horizon. So there are a lot of calculations that went into this particular cell. And we've assigned it the name here, R, because it's a result, mean costs A. Okay, so that is the mean costs for treatment A. Really important. We'll come back to that later. Let's now move on to the cost for treatment B. And this is very similar to what we did for A. We need to pull in the aggregated cost for treatment A in cycle 1 from the simulation sheet and then apply that discount factor. So equals, and then on the simulation sheet, we need to just go across. And this is where the hiding the columns might be useful. There we go. It's that one. And then I'm going to just go back to the discounting sheet and I need to multiply this by this discounting factor here. And remember, we need to think carefully about what happens when this gets copied down. We don't want row 24 to change to 25. So we're going to put that dollar symbol in. Okay, it likes it. Okay, so now it's shown all of the rows again, all the way down to iteration 1000, and we have to calculate the mean. And if you look at the formulas that we've got in here, we can just borrow that formula, right? Let's just copy that and paste it here. Okay. We're now on to step 12.7, calculate the bounds of the 95% credible range. And again, we had a formula here, percentile. If you remember correctly, it went back to, it was looking in column C to pull in the percentile, 2.5% or 97.5%, and it's looking in BM 49. Well, if we copy that across, it should work fine. So I'm going to just copy that and paste it here. Okay, so then it's hidden most of the iterations so that we can do the total cell. And as you remember, this formula here can just be copied and pasted here. And you can see there's another blue cell as well. So this blue cell is important. This is very much like the other blue cell, but this is for treatment B. So the average, the mean total aggregated discounted cost for treatment B, which we'll just call the mean cost for treatment B. But yeah, a lot of thought, a lot of calculations went into that cell. Okay, now we need to do the same thing for the qualies. Qualies for treatment A. So where can we find them? Simulation sheet. Keep going across. Here are the qualies for A. It's that one there. And we want to multiply it by this discount factor here, and we're going to lock row 24 again. Okay, so all of those rows have now appeared, and we need to do the mean again, and there's a pattern here, right? We just have to keep repeating the pattern. After this, there's only one more to do. Okay, and then we need to do the 95% credible range. So we will copy that formula there and we'll paste it in here. Okay, so that's opened up all of these rows again. And then, just like before, we need to do the total. And the blue cell has appeared. That's going to be the mean of the total aggregated qualies for treatment A, discounted qualies for treatment A. So we paste that formula in. Okay, and we're on to the last part of the 4 now. So this is the qualies for treatment B. So that equals, we go back to the simulation sheet, we pull in qualies for treatment B in cycle 1, we'll multiply that by this one here. There we go. Now we need to do the mean, so we can just borrow that formula again. And then finally, we need to do the 95% confidence interval, credible range, I should say. We're going to paste that here. Okay, so then all of the cycles have now opened up and we need to do our final total. We will borrow that formula from row 34 and we'll paste it into row 49. And again, we have this blue cell and it's been assigned a name. So this is a results cell. This gives us the mean qualies for treatment B. So all of the 4 blue cells on the sheet have been given names, and we will be using those names later in the exercise when we put together the probabilistic result sheet. So this final step of this task, take a look around the completed discounting sheet. You can use the check boxes to hide or unhide columns. So we could do that. We can hide the column here. And go across, hide the column here. And then go across, hide these. And this just makes the sheet much easier to navigate. Okay, and there's also a hide rows down here, which we can click, which will hide most of those iterations. Okay, so we have this, much easier to navigate sheet now. We have our mean. These are the really important values here. The mean discounted aggregated costs for treatment A in each cycle, which of course we've then got a total for. Then the same for the cost for treatment B. We then do the same for the qualies for treatment A, and then finally for the qualies for treatment B. And so that is task 12 completed. Let's tick this box. Okay, and now we're on to task 13, which is calculating incremental costs and qualies. And I'll see you in the next video.